In this part of the lesson, we're going to continue our graphing, and we're going to talk about what to do and how to tell if there are any holes in our graph. Now, mathematically, these are called graphical discontinuities. We're just going to call them holes, but that's fancy talk for discontinuities. So to tell if there's a hole, first we find the horizontal asymptote for holes. So we're going to factor. And if we have a factor that's the same on the numerator and the denominator, we're going to divide it out, and that's where our hole is going to be. So let's take a look at this question A. It says sketch without using the graphing calculator. So there's a lot of things we need to find out. First of all, I want to find out the horizontal asymptote. So look at your leading terms. We have x squared and we have x to the first. Bigger on bottom, that's a bobo, so y equals 0. That's our first step. Our second step is we factor. So the numerator says x plus 2. My denominator, I need factors of 4 that add up to 4. That's x plus 2, x plus 2. Now, notice on this one, this factor of x plus 2 cancels out. And be sure to leave a 1 on the top. If one of your factors cancels out, that's your hole. There is a hole at x equals -2. Your hole is at the 0 of whatever factor canceled out. So for my hole, I know the x-coordinate is -2, and now I'm going to find the y-coordinate. Once we divide out that common factor, we look at what's left. So this is the function I'm going to work with for the rest of the problem. So let's plug in -2. Well, what happens at -2 plus 2? Well, that's 0. Because -2 became my vertical asymptote. So this one is pretty crazy because there's not a hole, because -2 is an x-coordinate that can't be used because that's my vertical asymptote. So this one doesn't actually have a hole. It just has a vertical asymptote at x equals -2. And we have a horizontal asymptote at y equals 0. Kind of a strange example. So we go through our steps. We've determined the horizontal asymptote. We factored. Determined if there are any holes. This one didn't have any. Vertical asymptote. We got it. Now we're going to determine any zeros, roots, or intercepts. Your zeros, roots, or intercepts are what happens when the numerator equals 0. Well, in this particular problem, the numerator is 1. So there are no roots or zeros. No roots, because I can't make that equal 0. The other thing I could find is the y-intercept. Remember, we said the y-intercept is when x equals 0. So put in a 0 for x. The y-intercept is at 0, 1/2. So right about there. Now I know this is just 1 over x plus 2. That's kind of a parent function transformation. So I know it looks something like this. And there wasn't a hole because the value for the hole was actually undefined. So we're going to find another one that has a hole. Let's take a look at letter B. We have x over x squared plus 3x. So again, horizontal asymptote, we look for who's got the greater degree. The greater degree is on the denominator, so y equals 0. And let's factor it. My denominator is going to factor to x plus 3. And notice I have a common factor that's going to cancel out. There is a hole at x equals 0. Your hole is at the 0 of whatever factor you just divided out. To find the y-coordinate of my hole, I'm going to plug 0, the x-coordinate, back into what's left. Now remember, if your entire numerator cancels, leave a 1 on the top. So if I plug 0 in here, 1 over 0 plus 3 is 1/3. There's a hole at 0, 1/3. Now if we take this function, I think we already found the y-intercept because the y-intercept is the same thing as the hole. There are no x-intercepts because I can't make that numerator equal 0. So my graph, y equals 0, x equals 0 is the hole. So 0, 1/3. We never found the vertical asymptote. The vertical asymptote is what makes the denominator equal 0. And that was x equals -3. So I've got my hole at 0, 1/3. And then I just graph. I know what the graph of 1 over x plus 3 looks like. It looks like this. The only difference is there's a hole. It's undefined at that spot. All right, let's continue. Letter C. X over x to the third minus x. So we'll start with horizontal asymptote. Bigger on bottom, y equals 0. Now we're going to factor. Well, this denominator, I see it. That x squared minus 1 is going to factor again. Do you see the factor that's going to cancel out and leave us a hole at x equals 0? So we're going to put hole at 0 something. So my new function that I'm going to work with is 1 over, and x squared minus 1 is a difference of squares, so we're going to call it x plus 1, x minus 1. And if I plug 0 in to the denominator, I get 1 over -1, and there is a hole at 0, -1. So it tells you here, for your hole, plug the x value of the hole into the simplified function to find the y value. Now your vertical asymptotes are in your simplified function. What makes the denominator equal 0? Well, I got x equals -1, and I've got x equals +1, would make my denominator equal 0. After that, we look for y-intercepts and x-intercepts. And I don't have a y-intercept because 0, -1 is my hole right here. And I don't have any x-intercepts because my numerator is 1. I cannot make the numerator equal 0 if it's a whole number. So horizontal asymptote y equals 0. Vertical asymptotes at x equals -1 and x equals +1. So we got 3 sections. This one probably does a parabola. And on either side, we could test our points to find out that it does your basic L shape like the others did. Okay, this thing with the holes is confusing. Let's keep trying it. Oh, wait a minute. Do you see this one? X squared plus 5x plus 6 and x squared plus 5x plus 6. Well, going to call letter D a typo and move on to letter E. So here we go. So this one, if we're looking for a horizontal asymptote, notice that the larger power is on the numerator. And we had one that's bigger on top. There was no horizontal asymptote. Now we need to factor to see if there are any holes. So x squared minus 2x minus 15 is x minus 5, x plus 2. And my denominator is x minus 5. So I notice there's a common factor that's going to divide out, and I have a hole with an x coordinate of 5. You take the 0 of whatever factor canceled out. What makes x minus 5 equal 0? Positive 5. Now all that's left is x plus 2 on the numerator. That is a line. That is a linear function. So to find the coordinate of my hole, I plug my x value in. 5 plus 2 is 7. So what I have is a line, x plus 2, with a hole at 5, 7. So our next question, we've always found, what is the vertical asymptote? Well, there's no denominator, so there's nothing to make it equal 0. So there is not one. Do I have a y-intercept? Well, if I plug 0 in for x, I get 2. So yes, I have a y-intercept. Do I have an x-intercept or a root? Well, what would make the y value equal 0 if x was negative 2? So there's a couple of points I can put on my graph. I had no asymptote lines because this is just a linear equation. So there's a hole at 5, 7. So 5, 7, put a hole. 0, 2, negative 2, 0. And it's just a line. It goes through here and skips over the hole. Well, pretend like that's a line. And that's what happens if your denominator cancels out. Let's look at letter F. Oh, we didn't do domain and range. We forgot. Domain, all real numbers except asymptotes and holes. So there are no asymptotes, but x is not allowed to be 5. That was a hole. Your range, all real numbers except asymptotes and holes. There are no asymptotes, so we just take into account the hole. Let's look at letter F. Now this one, if we look for a horizontal asymptote, I have bigger on top, just like I had here. Bigger on top means none. Now we're going to factor this. So there's 4 terms on the numerator. I'm going to do grouping. So I'm going to group x to the third plus x squared and get this. And then 2x plus 2 gets grouped and get this. So my factoring is going to give me x squared plus 2 and then x plus 1 over x plus 1. So it factors. Notice I have a common factor that's going to cancel out and give me a hole at whatever makes x plus 1 equal 0, at negative 1. So all I have to graph now is x squared plus 2. That's a quadratic, but it has a hole at negative 1. So plug in negative 1. Negative 1 squared plus 2 is 3. There's a hole at negative 1, 3. There is no vertical asymptote because there's no denominator. There's a y-intercept because if I plug in 0 for x, I get 2 for y. Is there an x-intercept? Can I make this equal 0? Well, outside of using imaginary numbers, no, I can't. So there is no x-intercept. So think about graphing your parabola x squared plus 2. So my vertex would be at 2. I have a hole at negative 1, 3. And then I could just finish graphing my parabola. My domain would be all real numbers, except any asymptotes or holes. There are no asymptotes, so we'll just take the hole. And my range is real numbers, except asymptotes, which there are none, or holes. And there we have it. So we're going to practice a lot more on what to do when there's a hole, how to find it, how to state it, how to graph with it, and we'll get lots of practice with that.